All right, so let's take a look at when we want to evaluate some logarithms. And I'm going to be completely honest with you here. I'm hesitant just to go right into the graphing calculator because I want you to understand, and I know what's going to come up in section 4.5. And so I'm going to focus on one concept here, but because of time, I'm not going to stress on this. And because this is an online class, if all of these problems right here, and this goes back to my conversation in the last video, all of these problems right here are solvable. Like, these are all problems we can plug into our calculator. These are all problems that we can do because none of them have, have variables. They're log base 2 of 1. They're log base 9 of 81. They're log 1/4 of 64, so forth and so on. So we just plug these jokers in our calculator, man, and we just move forward. However, before I do that, because this is a higher level class, and because some of you are going to go into calculus, I would be doing an injustice if I didn't teach you why this is working. And so, and like I said, and in unit 4.5, I know where we're going, and so we need this. So here we go. I want you to think of this problem when you're solving it as being equal to x. I want you to convert this over to exponential form. So 2 to the x equals 1. So 2 to the x equals 1. Now, once you have this in exponential form, you can actually solve what the solution is. You know that any number raised to the 0 power is equal to 1. That means that x is equal to 0. Let's do another one and see if it kind of catches on. So we set it equal to x. We convert it. So we start at the base. We go around. So that's 9 raised to the x power is equal to 81. Well, what would you raise 9 to get 81? The answer is 2. So that means that this guy is equal to 2. That means this guy is equal to 0. We do it again. We set it equal to x. We swing it around. So now this is 1/4 to the x is equal to 64. Now that's a little bit harder to see, so I'm going to kind of pull out my calculator to help us see it. So if I did 4 raised to the 3rd power, I get 64. But I'm not 4, I'm 1/4. So essentially I need this 4. I need to think of this as being 1/4 to the x equals 64. So I need to somehow figure out how to get this from the bottom up to the top, and that's where that negative exponent comes into play. So we go math, 1. So I converted it back to a fraction so you can see, and that's where the 1/64. So in this case here, x is equal to -3. Now from here they get harder. So from here we have craziness. We look at this and we say, equals x, and so we say 3 to the x equals the 8th root of 3. Well, this is radical form. We can convert that to exponential form. So this is 3 to the x equals, and when I convert this to exponential form, this is 3 to the 1/8. Remember, the root becomes the denominator. Then we have a property that says if I have like bases, I can drop my bases and my answers and set my exponents equal. So I set x equal to 1/8. That's my answer. And then they continue to get more complicated. We go ahead and we set this guy up. We set it equal to x. I get the cubed root of x is equal to 81. But you know what, Joe? Guys, you can play around with that and figure out the answer. I mean, yeah, you may not be able to do that in your head, but you certainly can take your calculator and take the square root of 3 and raise it to some powers. Square it. Wow, that's weird. Okay, do it again. So second square root of 3, let's take it to the 4th power. Oops, sorry, that was a mistake. I'm just going to cheat here. Let's choose this one. We'll come back and we'll change that to 4. No, I'm getting closer. So let's cheat again. Arrow up, press enter. Let's change that to 6. I'm getting, so you see, you can use discovery to work your way to the solution, whereas with logarithms you can't do that. There's no way for you, so you can see here that x is equal to 8. There's no way for you to look at this logarithm right here and see that the answer will be equal to 8. Excuse me, there is a way using some properties that we'll get to, but we're not there yet. So right now we're just utilizing this idea of converting from one to the other. Okay. The only thing I really want to say about this guy right here is we're going to use our calculator for this one. But what I want to say to you is that there's an understood E right here. Okay, just like here, and I forgot to say this already, there is an understood, if you just have a logarithm and you hit log on your calculator right here, you hit log, you notice there's no base. It's understood to be base 10. And so let's go ahead and roll into that conversation now. So that means that if I'm fixing to try to plug these into my calculator right here, and I want to plug in log base 2 of 1, well, that is not the same thing. Like if I hit enter, I get 0, and you're like, oh, well, that's the same answer. That's because it's the same type of question. Let's do this one. If I did log, I don't have a way to put the 9 in, so I do 81, and that is clearly not the same answer. So that's because this is base 10. We live in a base 10 number system, so when you type that in right there, that is actually says log base 10 of 81. Well, we need a way to make that be log base 9. So in your graphing calculator, you hit the math key, and if you go all the way down to the bottom of the list, you have what's called log base. This is the shortcut. This is the fast way. It's like the fraction key. So I get this guy that pops up. Now you'll see compared to the other ones, there's a place to put my base. So I can put my 2, I can put my 1, I can press enter, there's my 0. Okay, math. Instead of going down all that, I can just go up, and it takes me down to the bottom of the list. I can choose letter A, and now I can go to the next one. I can do 9 to the 81. I get 2. Fantastic. Try a couple more here. Make sure you're seeing the process. So I go math, up arrow to choose letter A. I type in 1/4, 64, -3. And we can continue on. I'm going to go to this last one here. Excuse me. We'll do like no, you got the idea. You're good. Let's talk about ln real quickly because you don't type in the E right there. So we say ln, which is another button on your calculator right here. ln right next to the 4. You don't need the E, it's understood, so that red E is understood. But I need the 8th root of E. So I have to hit the 8 first, then I have to go to math, then I have to go down and choose number 5. So you can see how that puts it into the root for you. So one more time, you got your ln key, you got to type in your 8 because it's got to be out there first. Then when you go to math, you go down to number 5, and you can see that if you didn't put that 8 out there first, it wouldn't have a number to go right there. So it's kind of a key process. And then we do E. Well, E is located on the ln button. See it in blue right there? So you can do second E. And then when you're doing this in the calculator here, they don't have it, but you have to put an exponent on E. So you've got to do that like that. Let me press enter. So that's 0.125, which is equal to 1/8. All right, so that's evaluating logarithmic expressions.